Welcome to the presentation on the AIDEAS LCA evaluator, developed by Università Politecnica delle Marche within the broader IDEA solution for industrial equipment, repair, reuse, and recycling. This tool has been designed with a clear goal to support companies in making informed, sustainable decisions about what to do with their products at the end of their life. The LC Evaluator is a part of larger framework built by AIDEAS projects to promote circular economy practices in industrial settings. Its role is to assist in the evaluation of different end-of-life options like reuse, remanufacturing, or recycling by combining technical data and artificial intelligence to identify the most suitable path. From the initial design and manufacturing phases to the actual use of the product, the process is supported by artificial intelligence that enables data-driven decisions, helping industries reduce waste and recover value. But what exactly does the LC Evaluator do? In short, it helps companies choose the best end-of-life strategies for their products. It assesses each option using quantitative indicators such as CO2 emissions, energy use, waste generation, and cost. Based on this analysis, it ranks the alternatives and supports decision makers with clear and traceable recommendations. By doing so, the tool provides actionable insights that help managers adopt the most responsible strategy. Why is this important? Because today, many industrial products are discarded without proper assessment, resulting in wasted resources and environmental damage. The LC Evaluator helps reverse this trend by promoting reuse and recovery of materials, reducing costs and supporting compliance with environmental regulation and corporate sustainability targets. In addition, they can improve their public image by adopting transparent, measurable sustainability practices. How does it work? The system collects data from multiple sources, environmental databases like LCA and social LCA, and technical documentation. These inputs are analyzed using artificial intelligence, which simulate and compare multiple end-of-life scenarios. Factors such as energy use, logistics, material composition, and recovery potential are all considered. In the end, it also explains it in a clear and understandable way, so users know why a particular option is the most sustainable. The interface allows users to access to all the solution inside the task 6.3. This flexibility supports both quick assessment and long-term decision-making processes. It opens with a clean and intuitive layout, giving users the possibility to start a new or access previously saved project. By managing both new and ongoing projects in one place, the system ensures continuity, traceability, and ease of use throughout the decision-making process. The circle represents the components that need to be evaluated. By clicking on any of these circles, the user can access a detailed input form and enter all relevant information about that component. This step ensures that the evaluation is based on accurate component-specific data. The rectangles represent the processes, that is the possible action that can be applied to a component, such as a reuse, recycling, or disposal. By clicking on processes, the user can enter detailed information related to its environmental, economic, and social impacts. This allows the system to evaluate each scenario accurately and provide a well-informed sustainability assessment. Now, by clicking on the plus icon next to the process, users can add new processes or components that are connected to it. These features make it easy to build complex end-of-life scenarios by linking different operations and parts. Once added, each new element can be described in detail by entering specific environmental, economic, and social data, ensuring a comprehensive and customized evaluation. Once the algorithm is launched, the graph is analyzed to identify the best combination of activities that minimize environmental, social, and economic impact. The system evaluates all the possible paths and selects the most suitable sequence of processes. The results are then displayed by impact theory, showing detailed values for each dimension. On the graph, The optimal sequence is clearly highlighted in blue, allowing users to immediately visualize the recommended strategy with the full system structure. At the end of the analysis, the optimal solution can be saved and stored within the project. This allows users to keep a record of the recommended strategies and use it later to support decision-making processes. By relying on this data-driven outcome, organizations can ensure that their choices are both sustainable and well justified. To wrap up, we have explored how the AIDEAS LCA evaluator contributes to more responsible and sustainable industrial practices. Starting from a clear understanding of what the application does, how it works, and why it matters, we have seen how artificial intelligence can play a central role in supporting end-of-life decisions. By combining technical data, environmental indicators, and intelligent analysis, the application helps users choose between options like repair, reuse, and recycling, offering not just a recommendation, but a transparent and justifiable path towards sustainability. Through the demonstration, we have also seen that the tool is not only powerful, but user-friendly. It guides companies in evaluating alternatives with clarity and consistency, enabling more circular processes and better compliance with regulation and sustainability targets. Finally, LC Evaluator is more than a digital tool. It's a decision support system that strengthens the industry's ability to recover value, reduce environmental impact, and act consciously in every phase of the product life cycle. Let's continue to integrate this kind of intelligence into our system so that every decision we take leads to a more sustainable future.